This is my Ponderosa Pine debate essay alternative, and this is my outline so that you know that I'm not just going to be rambling at you for 10 minutes about this. So to start, I want to note that just due to the nature of this assignment, I felt like I was biased going into it because we were told to read the William and Baker paper, and then to read the correspondence to it, and then to read a news article on the debate. So as I was reading the Williams and Baker paper, I was already going into it thinking that it was wrong. But we'll analyze that paper first. So traditionally, historically, it is believed that western dry forests have widely spaced ponderosa pines that experience frequent low severity fires. And Williams and Baker tested or analyzed 3 hypotheses based on our current understanding or that traditional idea. So the first hypothesis is that the western dry forests are fairly uniform with those wide-spaced ponderosa pines and shade-tolerant trees. The second hypothesis is that low fire severity was more common in this region and high fire severity was rare. And then the last hypothesis that they were testing is that high severity fire has increased in the recent decades due to climate change and how we manage our forests now. So I'm going to focus on their methods for the severity hypothesis because I think I understood that one the most. So basically, they related tree size to tree age that they determined from past cores and aerial images. And from the tree size, you determine the size class structure, which will tell you the disturbance severity. And they cited a few papers that tell you or that supported the idea that you can relate age and size. The thing I noticed though was that all of the papers that they cited were pretty old. So this paper was written in 2012, and the research that they cited was from 1981, 2 from 1998, and then there was an independent study that supported it in 2005. That's the most recent one. So it kind of makes me question the accuracy and validity of this relationship. And moving on to some of their results, so they found that, and they had 4 test areas that they did, 4 different western forests, and they found that there was high tree density in all of these areas. So that disproves hypothesis 1 of the widely spread ponderosas. And then they found of those 4 forests, only one of them had a majority of low fire severity. The rest had high fire severity, so that disproves hypothesis 2, that low severity was more common than high severity. And then the third hypothesis was that high severity is more common now. But since they found that most of these forests had high severity previously, it means that it's not higher now. I hope that makes sense. So basically they disproved all 3 of those hypotheses. And then they also mentioned how our current forest management of fire suppression is changing what our historical fire regime was, because if it used to be high severity fires and now we are suppressing fires and doing prescribed fires so that we're having more frequent low severity fires, that's completely changing the fire regime. And it's also damaging to ecosystems. Like there are many bird species that need like burned habitats to live. So that's their paper. And then let's look at Fuels and other authors' paper, some of their debates to that. So first, they mention that in William and Baker's paper, they use the term higher fire severity, and for that term, they combined mixed fire severity and high fire severity. So basically, it kind of like makes their data lean towards more higher severity fires. They also mentioned that you can't relate size to age. So using the age of the tree, you can't determine the size class, and therefore you can't determine the fire severity. And they said that's especially true in ponderosa pines, which I would imagine in dry areas when there's not a lot of growth each year, it is hard to determine age or relate age and size. They were also mentioning post-fire response regeneration. So when they were looking at images, they were determining that there was a fire previously because there's new regeneration. Well, just because there's regeneration, it doesn't necessarily mean that a fire has occurred. Oh, I don't have water. Because regeneration can occur for many different reasons. It can occur after bark beetles or after periods of wet climate. They also did not define what fire severity was until the discussion of the paper. And when they were determining fire severity, they were using tree density, instead of number of trees that died and basal area damaged. And density does not relate to basal area or directly relate to basal area, so you cannot use those measures interchangeably. I'm sorry. I've got a tickle in my throat. So overall, this paper basically said that Williams and Baker is wrong. And then, God, I need water. The news article that just summarizes the debate. First off, this was written just by a journalist, so she is not a scientist, so when I was reading this, I took it with a grain of salt. But the first thing that I noticed was that she mentioned that Williams and Baker are recent PhD students. So when they wrote this, they were pretty young. And I think that needs to be taken into consideration in this debate, because students often can think about things and see things in different ways than people who have been doing this for years and are very experienced. So I think them thinking of new ideas and trying to see it from a different perspective is something to keep in mind. They're young PhD students. They're just looking at it from a different perspective, and I think that's something that we should think about. What else? Oh, this paper mentions that the Southwest model is used throughout the entire West, and even in areas that don't really have the same historical fire regime as they do in dry Southwest forests. So basically what I took from that is that you need to tailor your treatment for fires to your local conditions. You can't just take the Southwest model and apply it everywhere. So basically my conclusion after reading all of this is that in recent decades we can choose to suppress fires because of changing climate and droughts and whatever else. So we can choose to do that, or we can choose to leave it natural so that it keeps its historical fire regime. And there are pros and cons to both sides. So however you choose to do it, you're going to gain some good things, some benefits, and you're going to lose things. You're either going to lose ecosystems, or you're going to lose the historical, traditional value of it. So you got to kind of pick what you think.